A rental truck company has vans, small trucks, and large trucks. Okay. The company plans to spend $5 million on 200 new vehicles. Each van costs $20,000. Each truck costs $25,000, and each large truck costs $35,000. The company knows based on experience they will need twice as many vans as small trucks. Let X be the number of vans, Y be the number of trucks, small trucks, and Z be the number of large trucks. Find the number of each kind of vehicle they can buy. So just like all the ones we have, and most of your examples I hope look like this, you're going to have money and they're going to have totals. And when you put them together, you'll be able to solve for everything. So, all right, cool. Let's go through this and write down what we know. Okay, so they said they're going to spend $5 million. So $5 million on 200 new trucks, right? Okay. The vans are going to be 20,000. The small trucks, 25,000. And the large trucks, 35,000. Oh, 35,000. The company knows based on experience they will need twice as many vans as small trucks. They're going to need twice as many vans as small trucks. Twice as many vans as they have small trucks. Twice as many vans as they have small trucks. And then so let X be the number of vans. So X represents vans. Y's, I'm just going to follow it. Small trucks, right? And Z, large trucks. All right, let's get into it. Let's build our equations. I think the money one is first. What do y'all think? So let's do the money. Oh, there it goes. Okay, so $5 million on 200 new trucks. Oh, the count might be first. Oh. Yeah. Okay, so let's look at this one first. So that means the number of vans plus the number of small trucks plus the number of large trucks. That's 200, right? Because that's how many they're going to buy. So that's one equation. Now let's look at the money. They're going to spend $5 million. So that means 20,000, 20,000 for each truck plus 25,000 for each small truck plus 35,000, writing too big, for each large truck is going to equal 5 million. Okay, that's our second equation. So I write big. I'm gonna have to figure out how to write a little smaller. And then so we've taken care of that. And then the last thing we need to look at is this. There's gonna be 2 times as many vans as small trucks. 2 times as many vans as small trucks. So that means however many small trucks you have, you need your vans to be 2 times that. So twice as many vans as, what are my small trucks? Y. And if I write that as an equation, remember, you can move the 2x over here. Oh, no. Sorry. Twice as many vans as small trucks. This is backwards. Let me show you why. This should be x equals 2y. Twice as many vans as small trucks. So if I have 5, let me write this down. If I have 5 small trucks, then I need 10 vans. So if I take 2 times the 5, right, I get the 10 vans. So that's why I'm doing it this way. Okay, twice as many vans as small trucks. I need twice as many. So however many, I need to know however many small trucks I have, because I'm going to take 2 times that, and that'll give me the number of vans. Okay, so now I can take X and put it over here, or I'm going to probably do this over here because all of our equations are X, Y, and Z. So if I rewrite this, this is going to be X minus 2Y equals 0. So that's our third equation. See how we did that? So we took the 5 million on the 200 trucks. So we took this piece of that to get this equation. And then they said they were going to spend 5 million. Well, this is how much each truck costs. So see, we put all the money together. And then the last thing we did, we said they need twice as many vans as small trucks. So if I have 5 small trucks, I'm going to need 10 vans. So that's going to be 2 times the small trucks. So matter of fact, I don't want this to be confusing. I'm going to say twice as many vans as small trucks. And then right here, for example, 2 small trucks would imply let me do the 5 because I did 5. 5 small trucks would mean 10 vans. Okay, so that's what that, I'll put that little disclaimer there. Okay, all right. So this is our, let's build our system. So here's our system. We have, do my little 3. We have X plus Y plus Z equals 200. We have X minus 2Y, no Z, right, equals 0. Now, this equation is long. This one right here, sorry. Let me pull this down, because what can you do to this equation here to make it smaller? Because ain't nobody trying to deal with these big numbers, right? Ain't nobody trying to deal with these big numbers. So what can you do to make it smaller? Well, this has how many zeros? 1, 2, 3, 4, 5. That have 6. 1, 2, 3, 4. If I divide everything by 5, yeah, 5 with how many zeros? 1, 2, 3, 4 zeros. That'll make it smaller. So we're going to divide everything by 5,000. And you're like, well, how did you know to use the 3 zeros? Because you want to look at you want to find the smallest number of zeros. See, there's 3, that has 4, and that has 6. So if you can divide by the smallest number of zeros and then find a number that goes in common here. See, 35, 25, 25, well, 5. And then the least amount of zeros I can pull is that. So when you take 20,000 divided by 5,000, those 3 zeros go, and then you have 20 divided by 5, which is just going to give you 4. So that's kind of how it works when you're doing division. And I'm just doing this because I don't want to assume that people know that. You don't have to always reach for your calculator. So see, this has 3 zeros. Those 3 zeros, 25 divided by 5 is going to be 5. And then 35,000 divided by 5,000. Same thing. 35 divided by 5 is 7. And then, of course, you have your 5 million divided by 5,000. You only can take 3 zeros. So take 3. So you have 5,000 divided by 5, which is going to be 1,000. Okay, so that's kind of how it works when you have zeros. Zeros are great because they just make the math easier. So let me section that off. Okay, so now we have our smaller equations. So then I'm gonna write this as 4x, right, plus 5y plus 7z equals 1,000. Okay, and those came from here. Okay, when we did the division. Much better looking, right? Yeah, much better looking. Okay, so now that we have our system, we're going to do matrices. Okay, we're going to turn this into a matrix. So remember with the matrix holds the coefficients. If you haven't seen my video on how to solve systems with matrices, it takes all the coefficients and just the constant. So if I were to write this as a matrix, it would be 1, 4, 1, 1, 5, -2, 1, 7, 0, and then my constants, 200, 1,000, and then 0. Okay? That's what that system looks like as a matrix. Now we're going to start doing our row operations because our goal is to get x, like you want to have x, y, z in your constant. You want to have y, z, and then you want to have z, because whenever you have the z, you can plug it into here, get y and z, and then you can plug it in here and get x, y, and z. Go back and watch the previous video so that it makes sense to you what we're going to do. So remember, this first step is we want a 1 right here. We got it. Okay, we got it. We don't need to even do anything with it. The next step is we need this to be a 0. Okay, so step 1, that needs to be a 1. That's good. The next thing we want to turn, we're going to turn this into a 0, and then we're going to turn that into a 0, and then we're going to move on to the y. So our goal is to get rid of the x terms in these two equations, this one and this one. So in order to make this a 0, we have to do some row operations, right? So if we take, let me see, if we take -4 times row 1 and we add it to row 2, we'll get our new row 2. That should work. So let's take -4 times row 1. That's going to give me, and I'll just do it here. Let me draw a line here. That's going to be -4. I'm taking -4 times row 1. Okay, that's going to be -4, -4, -4, -800. And then we're going to add it to row 2. Row 2, I'm just going to write it in blue. So we have 4, 5, 7, 1,000. Just so you can see the difference. We're going to add this together. When we add it together, notice that this is 0. See that? Matter of fact, let me do it in black because we're going to write it in black. 0, 1, 3, 200. So this is my new row 2. So now when I write the matrix, we're going to have 1, 1, 1, 200. You're going to have 0, 1, 3, 200. Matter of fact, if it helps when I'm going through this, I can write the new one just so you can see which one we changed. And then when we move on to the next problem, I'll put it back to black, okay? How about that? So that's what it looks like. This became our new, this is our new row 2. So that's our new matrix. So now we start there. So we got rid of the x from the second equation. Now we need to look at this equation, or now that it's a matrix, this row, I need this to be a 0. It's a 1. So I could probably take -1 times row 1, add it to this row, and that'll give me a 0. Okay, so let me write what I'm going to do. I'm going to take -1 times row 1. I'm going to add it to row 3, and I'm going to get my new row 3. Okay, so let me draw a little line here. So -1 times row 1. So I'm taking -1 times row 1. That's going to give me -1, -1, -1, -200. And then I'm going to add, I'm going to do this in green. Add my row 3, 1, -2, 0, 0. And then that should give me my new row 3, right? I'm going to say my new row 3. So when I write that, that gives me 0. That gives me -3. That gives me -1. That gives me -200. This is 4. Do that in green. 4, 5, 7, 1,000. So far, so good. Okay, so now when I write my matrix, what it looks like now, I have 1, 1, 1, 200, 0, 1, 3, 200, and then my new row 3, 0, -3, -1, -200. Okay, so far so good. All right. Put my little arrow here. All right, so now our goal is we got rid of the x coefficients on equations 2 and 3. Now I need to get rid of, so I have x, y, and z. I have y and z because we need this to be a 1. That's a 1, so we're done there. I need this now to be a 0. Okay, because remember our goal is x, y, z constant, a yz, another constant, and then z. Because once we figure out z, we can plug it, we can go back substitution. So this looks good. This looks good. I need this to be a 0. Okay, so what I'm going to do is I'm going to use, I guess I can use row 2. Yeah, because there's a 1 here. Let's use row 2. I'm going to use row 2 because I can't use row 1. It'll put a 1 back here. I need a 0 to stay there. Okay, so we're going to take 3 times row 2. We're going to add it to row 3, and we're going to get our new row 3. So we have 3 times row 2, 3 times row 2. We have 3 times 0, 0. Get my pen. 3 times 1 is 3. 3 times 3 is 9. And 3 times 2 is going to be 600. And then our row 3 is this. We're going to add those together. And when we add those together, we're going to get our new row 3. Row 3. So we end up with 0, 0, 8, and 400. Perfect. So this is what we have now. We have 1, 1, 1, 200, 0, 1, 3, 200, and then we have this new row, 0, 0, 8, 400. Can we stop here? Yep, we can stop here because now we have the z by itself. So that means, why did I put 8, y'all? Oh, sorry, we can't stop yet. Hold on. This shouldn't be an 8. I need this to be a 1, right? Because this right here represents 8z. I'm moving too fast. This represents 8z. So what we can do is we can just divide. Yeah, we'll divide everything by 8. Sorry, one more step. Take 1/8 times row 3 and get your new row 3. I was like, oh, we done. Okay, this has to be a 1. This needs to be a 1. We don't want 8z. We just want z. So when I divide that by 8, that's going to be 0 divided by 8. We're looking at this row. Okay, that's going to be 0 divided by 8. 0 divided by 8. 8 divided by 8. And then 400 divided by 8. Okay, so this is our new row 3. Again. Okay. So we got 1, 1, 1, 200, 0, 1, 3, 200, and then 0, 0, 1, 200. Now we can say, oh, hold on, that's not right. Y'all see what I did? 400 divided by 8. Y'all probably like, what? That's going to be 50 because 8 times 5 is 40. Good catch, y'all. Good catch. 800 divided by 400 is 200, y'all. But 400 divided by 8 is 50. Okay. All right. So now we're good. So now we have what we need. So if I were to change this back to a system of equations, we would have x plus y plus z equals 200. Y plus 3z equals 200. And then z equals 50. Y'all see that? The coefficients line up. So these represent the coefficients. These represent the constants. So these are your coefficients. And you had 3 and then 200. So now we can solve, right? So now we can do back substitution. Okay, we can do back substitution. We know z is equal to 50. So now we need to do y plus 3z equals 200. So y plus 3 times 50 equals 200. So that's going to be y plus 3 times 5 is 15. Right? And then we're going to subtract 250 on both sides. Or subtract 150, excuse me, on both sides. That becomes 0. So you have y plus 0 equals 50. So y equals 50. So we got y equals 50. We got z equals 50. And now we have x plus y plus z equals 200. X plus 50 plus 50 equals 200, right? X plus 100 equals 200. We're going to subtract 100 from both sides. That becomes 0. X plus 100 equals 100. So x plus 0 equals 100. And so x equals 100. Woo! That's right. So 100 vans, 50 small trucks, and 50 large trucks, which that makes sense because remember they said they need twice as many vans as small trucks. So if they had 50 small trucks, they're going to need 100 vans, 2 times 50. So we know we did that part right. All right.